about 20 minutes at the end where we can catch up whatever we need to catch up on. Okay, so times 180 over pi, and then cancel anything out that you can cancel out. So the pi's will cancel. 12 and 180 can both be divided by 12. So 12 divided by 12 would be 1. 180 divided by 12 is 15. And then you can multiply across. So negative 7 times 15 is negative 105. 1 times 1 is just 1. So 105 degrees is the answer. Okay, for number 2, we're going from degrees to radians, so we multiply by pi over 180. You can simplify before you multiply across, so 72 and 180 can both be divided by 9, stands out to me. So if I divide this by 9, I get negative 8 and 20. Then 8 and 20 can both be divided by 4, so that would make this 5 and this negative 2. So that I get negative 2 pi over 5.
What did you divide?
Okay, so number 3, it says draw an angle with the given measure in standard position. For these, I didn't include any that were radians. I only included ones that were degrees, so it should be pretty simple. You'd be looking at a bunch of coordinate planes, because remember it's multiple choice, and you're looking for the one that shows this degree measure. So your initial, right, is right here, and then negative means it's going counterclockwise, so this would be negative 90, negative 180, negative 270. That. And negative 315 would be around here. So it would go all the way around this way. Number 4. Number 4 deals with trigonometry and angle of elevation. It says a roofer props a ladder against a wall so the top of the ladder reaches 30-foot roof that needs repair. If the angle of elevation from the bottom of the ladder to the roof is 55 degrees, how far is the ladder from the base of the wall? So I'm going to sketch out a little picture. Let's call this the house. And here is our ladder to the roof. Okay, the height here, it says it's 30 feet. And then the degree measure of this angle is 55 degrees.
You have done it the opposite way.
Yeah, it would be the same thing. And then it wants to know the distance from the ladder to the base of the wall. So you're looking for this measure right here. Okay, so we're going to use trigonometry, SOHCAHTOA. And we have from this angle, opposite and adjacent, so we're going to use tan. And trying to find room to write this out. It'll be tan of 55 is opposite over adjacent, so 30 over x. And this is the format where it takes an extra step because that x is in the denominator. So we're going to multiply both sides by x. X tan of 55 equals 30. And then divide both sides by tan of 55. So 30 divided by tan of 55 is what you would put in the calculator. And it comes out to 21, I think it's like 0.2 feet. But it says to round to the nearest foot, so 21 feet. The next few are just practicing trig, very basic. This is an angle. We're finding the missing side. This would be opposite and adjacent. So just by coincidence, it is tan again. Tan of 64 is opposite over adjacent. Then multiply both sides by 11. Plug it in the calculator, and you get x equals 22.6. Okay. Then number 6, it says use a calculator to find the measure of angle B. So we'll just call this B degrees. And we have opposite and adjacent. So again, another coincidence, but it's going to be tan of B degrees is opposite over adjacent. And people often forget how to plug this into the calculator, but to find this degree measure, you would use the inverse tan, or tan to the negative 1, like this, and it would work. And it comes out to, so B degrees is 60.26. Next, it wants to find this measure based on this angle. We have opposite and hypotenuse. So based on SOHCAHTOA, we need to use sine. So sine of 20 degrees is x over 32. Multiply both sides by 32. And x equals 10.94. Okay, so now we're going to transition to chapter 10, which was on circles. Now, the circles chapter had a lot going on, but I kept the exam questions really simple and straightforward. We're going to strictly focus on equation of a circle, because I know that if you're taking SATs or anything like that, this is what's likely to be on those kind of tests, not all the little details that we went over in chapter 10. So we're keeping it simple with chapter 10. We're just focusing on equation of a circle. To remind you, the equation of a circle is x minus h squared plus y minus k squared equals the radius squared. And HK is the center, so the center is HK, and then radius, of course, is R. Okay, so for number 8, it says find the equation of a circle whose center is at 2, 3, and radius of 6. So we just plug in the numbers. X minus 2 squared plus y minus 3 squared equals 36. And that is it. That is it, yeah. Okay, for number 9, I tried to include what if type situations. It says the center is at 0, 0. That would be x minus 0, y minus 0, which would just be x and y. So when we write it, just say x squared plus y squared equals 16.
Where's 16 come from?
4 squared. The radius squared.
Gotcha.
Yeah. Okay, number 10. Find the center of the circle whose equation is this. So it would be negative 11 and positive 7, because remember the signs are opposite because there's a negative symbol in the equation. Okay, number 11, it says find the equation of circle P. I think one of the hardest parts of this problem, they should have bolded this line so that it stands out more. So this is the x-axis, this is the y-axis, and if you can find that, the rest should be easy. So we're going to find the center and the radius, and then from there we can write the equation. So the center of the circle is at 1, 2, 3, negative 4, 2. And the radius is 3 units. And then plugging that into the equation, it would look like this. X plus 4 squared plus y minus 2 squared equals 9. The next one is a little bit more challenging. We're going to actually do this on the back. It just takes more steps. So just turn your paper over and we're going to solve this on the back where we have more space. So the problem is x squared plus y squared plus 2x plus 6y equals 26. For this, we are trying to get it into the other format, and these are the steps we're going to take to get it into the other format. So we have to, 1, group it, 2, complete the square, and then 3, just reformat it so we can pull out the center and the radius. Okay, so what I mean by group it is you have to put the x's with the x's and the y's with the y's. So x squared plus 2x plus blank and y squared plus 6y plus blank equals 26. Okay, how do we figure out what goes in the blanks? There is an equation for that. It is b over 2 squared. What is b, you might ask? Well, this is a, b, c. So for this part, b is 2. 2 over 2 squared. That would be 1 squared, which is just 1. And then whatever you add to this side of the equation, you also have to add over here. That's supposed to be 1. Yikes, I should use whiteout at this point. Okay, so plus 1. Okay, and then for this one, same thing. You have your a, b, and c. So your b is 6. So 6 over 2 squared. 3 squared is 9. Put a 9 here and add a 9 to the other side as well. Okay, then at this point we factor this. We need two numbers that multiply to 1 and add to 2. So that would be x plus 1, x plus 1. And then over here, 3 and 3 would multiply to 9 and add to 6. So y plus 3 equals 36. Okay. Then we are going to reformat this. So x plus 1 squared plus y plus 3 squared equals 36. And now it's in the format we need to find the center and the radius and graph it if we need to. So the center would be at -1, -3, and the radius would be 6, the square root of 36. So that is our answer. And I believe on the test, or like for the exam, it's multiple choice, but there'll also be graphs. So you're just looking for the graph with the center at -1, -3, and a radius of 6. Okay, so go ahead and flip it over.
What was the radius?
6. Okay, so flip it over. Now we're going to go back to chapter 9. Chapter 9 was logs. It was really fun. So we're just going to go over it step by step. Like I said, you'll be able to use this on the exam review. A lot of this stuff I wouldn't even be able to remember off the top of my head. It's just like so many like different situations. But you'll be able to use this as a guide. So just on the exam, match the question and then follow whatever steps they have that is listed here. So for 13 and 14, well, we'll start with 13. To solve for x, what we have to do is get the same base, and then we can set x equal to the exponent of the other number. Okay, so what I mean is we're going to break up 729 into its smallest factors, which happens to be 3's. So breaking up 729, 9 and 81 is what I'm going to use to start. Okay, so all of its smallest factors are 3. So we need to count how many there are. 1, 2, 3, 4, 5, 6 3's. So 3 to the x power equals 3 to the 6th power. And so therefore x equals 6. for the next one, there is a small little formatting issue here. This x should be up here. And so we're going to do the same thing. We're going to try to get down to base 6, and then we can set the exponents equal to each other. So 7,776, I used 36 divided by 36, and if you divide this by 36, you get 216. So 36 can be broken up into two sixes. 216, you can divide that by 36, and you'll get 6. And then there's all the 6's. Okay, so there's 1, 2, 3, 4, 5 of them. So we say 6x plus 3 equals 6 to the 5th power. And then from here, because your bases are the same, you can set x plus 3 equal to 5. And x equals 2. Next. Okay, write each expression in radical form, or write each radical in an exponential form. These are actually really simple. They just want this written with an exponent instead of the radical. So square root of something would be the same as 37 to the 1/2 power. So that's what they're looking for. Then for the next one, to the 1/3 power would be the same as cubed root of 512. Okay, next, you see a log. That's fun. We learned a saying that is going to help with a lot of these problems. The saying is base is the base, exponent at the end. So this would be log base 6. So that 6 is the base, and the exponent's at the end. So it just wants us to write it in exponential form. We're just rearranging it. Base is the base, exponent at the end, equals 216. And that's what it's looking for there. Okay, then back up to the top, write each equation in logarithmic form. So now we're working backwards. Remember, base is the base, exponent at the end, base is the base, exponent at the end. Okay, so this is the base here. This is your exponent. So base is the base, so it would be log base 3. And exponent's at the end. And then you just fill in the 81 right there. And that's your answer. Okay, for number 19, it says solve this. There is a little formatting issue. This x should be up here as an exponent. This x should be like 2x. Okay, so what we need to do is we need to have the same base so we can set the exponents equal. So 32 can be broken up as 4 and 8. So we're going to rewrite this. The first part, 8 raised to x plus 2 equals, and this would be 8 raised, and you take that 4 and you put it here, 2x plus 4.
It can be factored more, we usually don't.
We don't because we want the base 8.
Why did you multiply by 4?
We'll go with it. Okay, so we're going to set these equal. X plus 2 equals 8x plus 16. I have to go back and try it the other way and see what it comes out to at some point. Okay. I'm like triple checking. Yeah, it says the answer is -2. Okay. Number 20. It says log of 3 x minus 5 equals log of 3 3x minus 25. Because you have the same log right here, you can just set x minus 5 equal to 3x minus 25 and solve the equation. Plus 5 plus 5. -2x equals negative 20, and x equals 10. Okay, so for 21, we're going to write it in exponential form, base to the base, exponent at the end, and then we'll solve from there. So it would be 3 to the 5th power equals 4x minus 17. And I'm running out of room. I'm going to just solve this on the back. So I'm flipping this over and just going to solve it on the back. 3 to the 5th power equals 4x minus 17. Did I remember that right? Okay. So then solving this 3 to the 5th power, you can plug that into the calculator, and it comes out to 243 equals 4x minus 17. And x equals 65. Okay, next. For number 22, it's just plugging it in a calculator. If it doesn't say what the base is, that means the base is 10. And if it's log base 10, you can just plug it in the calculator and get the answer. Dun, da, 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 0.3424. Bonita. Okay. 23. 5a equals 120. We're going to do this a little bit different. We're going to put log on both sides. So log of 5a equals log of 120. Log base 10 on both sides. Then we're going to take this exponent. So this exponent can be brought out front here. So it would be a log 5 equals log 120. It is to divide both sides by log of 5. And when you divide it in the calculator, it comes out to 2.97. So flipping this over, what is the problem? It's 5w plus 3 equals 17. Okay, so we're solving this almost the exact same way. Log of 5w plus 3 equals log of 17. We're taking this exponent and putting it out front. And yes, I'm going fast because I'm running out of memory on my laptop, so that's fun. This, you just plug it in a calculator, you get this number. And w equals negative 1.2396. Okay, I'll pause it so you can catch up. So we're going to cross out 25. Cross it out. We're not doing it. Then 26 through 29, what we're going to use is we can use ln to cancel out this e, and we can use e to cancel out the ln. So for 26, we'll do ln on both sides, and that causes this to cancel out, and then you get x equals ln 5.8. You would plug it in the calculator and get this number. Okay, next one, same thing, ln to both sides, get the e to cancel, negative x equals ln 31. Plug in natural log 31, put on a negative sign, and you get negative 3.43. Now we're going to use e to get rid of the ln, so we'll put e on both sides. Then we get 2.5x equals e to the 10th power. Divide by 2.5 to get x by itself. And in the calculator, you can just plug in e to the 10th power. So it's e to the 10th power divided by 2.5, and you get the answer. Put e on both sides to get rid of the natural log. Then x plus 2 equals e